Welcome to eAcademy. In this episode, we will continue discussing the basic information needed to get started with setting up a KNX system. Previously, we presented, among other things, the topology of a KNX TP installation. We showed what a line might look like, how to use line couplers to connect further lines to form an area, and how to connect multiple areas together. We also demonstrated how many devices can be installed in a line, in an area, and in a network of several areas. Today, we will move on to discuss how the devices are addressed and explain how the devices communicate with each other. Okay, so let's start by saying that each device in the KNX TP network has an individual address associated with where it is located in the installation. The individual address is in the form of 3 numbers separated by dot, for example 1.1.10. Its structure is 16-bit and is composed of the following elements. The designations A, L, and B used here stands for area, line, and bus device. The first address component corresponds to the area. A number between 0 and 15 can be used here. The 0 in this position is reserved for the addresses of bus devices located on the backbone line. In turn, numbers from 1 to 15 are used to address subsequent areas. The second number corresponds to the line number. As before, also here we may use numbers in the same range. If there is a 0 in the second position of an individual address, this means that the address refers to the device located on the main line of the chosen area. The remaining numbers from 1 to 15 are used to address the secondary lines in the area. Now the third part of the address. The number placed here indicates a specific bus device. The range of these numbers is wider, as it ends with the number 255. A 0 in the third position of the address indicates the line coupler through which the respective secondary or main line for the area is connected. The numbers from 1 to 255 simply address the subsequent devices on the line, and so here we can find backbone couplers of each area. The backbone coupler of the first area is assigned with address 100. For the last area, the address of the backbone coupler is 1500. Below the line couplers are located. The coupler of the first line in the first area has an address of 110. On this line behind the coupler, 2 other bus devices are also marked, the first and the last ones. The address of the first is 111, which stands for Area 1, Line 1, Device Number 1, respectively. The last device, therefore, has the address 11255. On the line number 15 located next to it, we have also marked the devices, first and last. In this case, they have the following addresses, 115.1 and 115.255. It is worth adding that most new devices, regardless of their manufacturer, have the highest available address, so it is 15.15.255. You can, and in fact should, change it during programming. Summing up, individual addresses, also referred to as physical addresses, tell us where a particular device is located in the installation. So they can be compared to postal addresses. The area number is like the name of the city. The line number would correspond to the name of the street and the number of the bus device to the number of the building. Let's move on. In addition to individual addresses, there is also another addressing in the KNX system. We are talking about group addresses. What are these? But let's first explain the so-called group objects, which are configured in the memory of each KNX device. Group objects refer to the functions of these devices, for example, switching on/off a group of lamps, raising, lowering roller blinds, brightening, dimming lighting, calling up a scene, etc. In the case of a simple button, group objects can be, for example, short push, push and hold, double push. Group addresses are used during the communication between devices in a KNX system, and these addresses connect the group objects to each other. In other words, the address assigns to a given group those group objects that should work together, so that a given functionality can be activated and used. We can use the group address to link together such actions of individual devices, as, for example, when the selected button is pushed briefly, the light should be on or off. Or when the button is pushed and held down, the roller shutters can be raised or lowered. Alright then, So how do KNX devices actually communicate with each other? Well, this is done via so-called telegrams. Among other things, they contain data on the individual address of the device that sent the telegram, the group address, that is the information on which group of functions of the selected devices is the recipient, as well as the type and value of the group objects, that is, with which value the mentioned functions are to be activated. For example, 1. Object active, 0. Object inactive, or with a selected percentage value. In order to use the functionality of simply switching on the lights in a room, we first need to create a group address where we combine group objects. From the actuator that turns on the light, for example a dimmer, and from the sensor that will trigger the action, for example a wall switch. If we would like to extend this to another point, for example another lamp or an additional switch, we simply add another group object from the selected actuator or sensor to the group address. On the other hand, a new group address would have to be created to implement the dimming function of the same light point, as this will be a different functionality. Important note, group addresses can contain group objects of sensors and actuators, regardless of where these devices are physically located. That is, in which line or area of the installation. There are some restrictions on the flow of telegrams through couplers. However, these are too detailed issues for this episode. In terms of the number of group addresses available, we now have as many as 65,535. In installations created before 2018, there were half as many. Okay, let's now move on to the addressing method. Well, group addresses in the KNX system can be described within one of three structures. The most common, 3 level 1, like the individual address, is in the form of 3 numbers. In the group address, instead of dots, they are divided by slashes. The first level of the address refers to the main group, the second to the middle group, and the third to the subgroup. Note that in each group, the range of numbers is different. In the main group, we can enter numbers between 0 and 31. In the middle group, between 0 and 7, and in the subgroup, between 0 and 255. The second type is a 2-level structure. Here we have 2 numbers divided by a slash. These indicate the number in the main group and in the subgroup. The numbers in the subgroup can be from 0 to 2047. The last is the so-called free structure, where the group address is simply a number in the range from 1 to 65,535. We mentioned earlier that the 3-level structure is the most popular. How is it used in practice? The best way to discuss it is with examples. Under the main group number, the system designer can indicate, for example, a room or floor of a building. A middle group can specify the type of function, i.e. control of roller shutters, lighting, gates, etc. A subgroup, on the other hand, will indicate the specific function of a particular device or group of devices. For example, the address, say 315, may specify 3. Living room. 1. Roller blind control. 5. Roller shutters in the window on the right, upward movement. In the same example installation, group address 321 can be read as 3. Living room. 2. Control lighting. 1. Switch on all lights. And 323 could mean switching on only the lamp above the table. Many combinations can be prepared. And now finally some important information. While individual addresses within a single installation are usually assigned only once at the beginning, group addresses can change depending on the changes of the functions. Although a sensor group object can be assigned to several group addresses, the telegram associated with this object, when sent by the sensor, will only contain the first programmed group address. In practice, this means that, for example, information about a button being pushed will only go to the first group address. The group object of an actuator, on the other hand, can be assigned to several group addresses. The function of this group object will be performed in any case, regardless of which of these group addresses is invoked in the telegram. Thus, for example, a lamp can be recalled in 2 group addresses and will be switched on/off, no matter whether you have used the switch sensor that was assigned for the first or the second group. Important note, Only group objects of the same type can be assigned to one group address. This means, for example, that the on-off function and the light brightness change function cannot be directly linked within one group. The functions of switching on-off and dimming-brightening the light must be split into two different group addresses. Okay, this concludes the discussion of the basics, the knowledge of which is indispensable to get started with the KNX system. Thank you, and see you in the upcoming eAcademy episodes. Until then.